My name is James Hart and I'm convener of C3 System Environmental Performance. The scope of C3 covers the identification and assessment of all of the environmental impacts from an electrical power system. C3 currently has 12 active working groups. One of those is a joint working group, as well as an advisory group on EMF and health. Now I'm going to cover a couple of topics in this body of work, and the first of which relates to the advisory working group. This group is aiming to publish 3 documents this year, one relating to EMF and DC fields, one relating to EMF and smart meters, and one relating to EMF and medical implants. So the first topic is medical implants. Under certain circumstances, medical implants can experience interference from electric and magnetic fields produced from an electricity network. Medical implants are generally immune up to the public exposure limits, but there are some things to consider. Firstly, the limits in Europe are different to what they are in the US and in Australia. There's also high field environments as shown on the left there. In those environments, you would expect the levels to be higher than the public exposure limits. And also some of the devices have sensitivity settings, which if put on their maximum setting can have resulting thresholds well below the guidelines. In terms of occupational exposure, it's important that businesses have processes in place such that workers can come to the business, inform them they've got a pacemaker, they can bring along information from their physician and the manufacturer, which identifies circumstances where they can be interfered with, and then a plan can be developed. In terms of public exposure, the public is generally restricted from those areas on the left, but there are some circumstances, such as under a very high voltage power line or in some cable tunnels which might be accessed by road workers and the like, where levels could be exceeded. In these types of settings, an option is to use signage at the entrance to manage that risk. The next topic I wanted to discuss is net zero by 2050. Australia has just signed up to that target, but that aside, and that will have implications for our industry, but that aside, we're already seeing investors and bankers that are wanting to see our sustainability performance and how we're managing and tackling climate change. I'm aware of one company in Australia that signed up to net zero by 2050, and I expect more will follow. Emissions can either be direct emissions or indirect emissions. Indirect are either upstream or downstream activities. In Australia, if a business exceeds a certain threshold of emissions, they're required to report on Scope 1 and Scope 2. This graph shows typical emissions for a network business. The 4 key contributors are network losses, SF6, electricity and transport, although network losses make up 95%. If we were to make an assumption, which is probably reasonable, that by 2050 we'll be driving around in electric vehicles, the energy mix will be largely renewable, then most of these emissions are going to drop away with the exception of SF6. This graph shows that a bit more clearly. In this particular case, you can see electricity use has been decreasing, in part due to the increased renewables in the generation mix, but also in this case due to downsizing and rationalisation of offices. Transport has remained fairly constant, but SF6 continues to grow. And this only projects up to 2024. You can imagine what this graph would look like at around 2050. The problem here is that we're installing equipment today that has a life of 45 or 50 years, and the 2050 is less than 30 years away. I don't think anyone knows what the government's position in 20 years is going to be in relation to SF6 and whether it should be taxed or penalised or phased out or removed, and hence it's a risk which needs to be managed. A number of companies are developing strategies. The strategies are looking at trialling alternatives, phasing out SF6, minimising leaks and improving reporting. Some companies have developed apps on the iPhone to track cylinder usage and measure the weights before and after and identify if leaks were present. So the way the cylinders work, they identify a cylinder either typing it in or via a QR code. It then takes them to a screen that gives them all the details about that cylinder. And then the app requires the user to identify the location. In this case, we're at Engadine Zone. And then we need to weigh the cylinder. So the previous activity was about to top up leaking equipment. So the activity required would be finish top up leaking equipment. If the user was to enter the incorrect activity, the app identifies a missed weigh or an error. So the user then goes back and enters in the correct activity. And in this case, the cylinder weight is 76 kilograms, which is a reduction and a loss equivalent to 52.8 tons of CO2. So the user then submits the form. All that information goes into a database which tracks losses and leaks in terms of equipment and location, and if there's any errors, and can send out email reminders or notifications if there was a missed weigh. So there are just some examples of things that are happening that I thought might be of interest to some people. Before I formally hand over to the new convener, I just wanted to thank CIGRE Australia for the opportunity, and here's a very brief summary of my last 6 years. One of the benefits you'll often hear about CIGRE is just the benefit of establishing a network of contacts from around the world, not only in terms of expertise, but developing friendships and being able to look at things from a different point of view. In my case, there was about 30 different countries, and when you get that many people in a room, there's always a different point of view that challenges and forces you to look at things from a different perspective. My company has oil-filled cables, and we've revised our process of draining those cables once decommissioned to a point where we're recovering close to 100% of the free oil. Previously, it was 60%. And that revised process all started with a conversation over dinner after one of these CIGRE meetings. Other benefits derived from CIGRE include development of an environmental risk model, which was used to underpin our oilfield cable replacement program. The model was presented to the EPA, who endorsed our program. We've also developed a new standard construction for dual circuit 132 kV cables, which substantially reduces the magnetic field. And probably the highlight was leading the development of a working group technical brochure. This provided access to industry experts around the world, including professors and doctors, which wouldn't have been otherwise possible without CIGRE. We're able to utilize all of this knowledge from these members and present it in a way that was applicable to the Australian context. And so we're able to bring that back to Australia and provide real tangible benefits to the industry. So now it's time to formally hand over to Brett Haywood, who is the new convener for the Australian panel C3. Brett is currently the Environmental Services Manager at Essential Energy, which covers the bulk of New South Wales. He's got 20 years experience in mining, petroleum, generation and electricity networks. As you can probably gather from the photo, Brett is a bit of a character, but his experience, he knows what he's talking about, and he's always willing to contribute. I think Brett will make a great addition to the committee, and I wish him all the best. Also, finally, I'd just like to thank CIGRE Australia for the opportunity that was given to me. Thank you.